Hello and welcome to section 5.5 on the average value of a function. Suppose it is necessary to compute the average value of a function f on an interval ab. How would one go about computing this value? The average value of a finite number of values y1 through yn is their sum divided by n. For a function f, we can divide the interval ab into n subintervals of width delta x, which equals b minus a over n. Now, rather than creating rectangles to find the area, we will use the endpoints of the subintervals to create an approximation of the average value. The average value f average on the interval ab is approximated by the sum of the heights of the endpoints divided by n, the number of endpoints. Manipulating the equation delta x equals b minus a over n, we obtain n equals b minus a over delta x. And inverting the equation, we find that 1 over n is delta x over b minus a. Replacing 1 over n with delta x over b minus a, we have a new way of approximating f average. The larger n gets, the more values we are averaging. So the limit as n approaches infinity of these approximations is the actual average value of f on the interval ab. That is, the average value f average on the interval ab is the integral from a to b of f divided by b minus a. To remember this formula, the value f average represents the average height of the curve, while b minus a is the width of the interval. The integral represents the area. So just like in a rectangle, the height is equal to the area divided by the width. The mean value theorem for integrals states that a continuous function f on the interval ab attains its average value for some c in the interval ab. Graphically, given a continuous function f on the interval ab, the average value of f would be the height of the rectangle sharing the base interval ab, whose area is the height under the curve. Imagine the curve as a pile of sand, which when leveled is the red rectangle. Let's take the polynomial 1 plus x squared on the interval -1 to 2. The average value of f is found by integrating from -1 to 2, and then dividing by 3 the length of the interval. Using the fundamental theorem of calculus part 2, the average value of f on the interval -1 to 2 is 2. Now, as f is continuous, the mean value theorem for integrals guarantees a value c in the interval for which f of c is equal to the average value. Setting f of c equal to 2, we solve for c to obtain c is equal to -1 or 1, both of which lie in the interval.